I'm Rod Fujita. I'm a scientist with the Environmental Defense Fund. And Laura asked me to talk about bringing science to action. And I guess the first thing I'd like to say about that is that it's great to have a team like this, with really talented natural scientists, people with really excellent quantitative skills, folks who work in the government and understand how governments work, and a whole cast of characters who lend all these different perspectives to the enterprise of designing research that will matter and then delivering that science in a way that it matters. Reminds me of the elephant metaphor. So you've got four very myopic people trying to understand what an elephant is like, but they can only see this far, and one of them's kind of looking at the trunk and concludes that it must be snake-like, and the other is looking at the leg and it must be like a tree, and another one is feeling the ear. You get the idea, right? And once they communicate, they get beyond these narrow lenses and start to get a better picture of what the elephant really is like. And that's how we scientists, so we have these narrow lenses. We can only see a piece of the puzzle. And so it's really important to put together this sort of interdisciplinary team to get a more accurate view of things. The other thing I want to say before I dig in is Laura asked me to explain to you that I won't be using a PowerPoint for these remarks, and I'm also not going to use any thrilling videos or pretty pictures. I'm just going to talk to you. So let's imagine,
So deal with it.
Yeah. So let's imagine for a moment that we live in an ideal world where science is perfectly integrated with management. What does that look like? It looks to me like managers are seeking out new science. They're very receptive to it. As soon as new insights are generated, they apply those results in a logical and systematic way to adjust targets, to set new limits, to work with their stakeholders to address the drivers that scientists have told them that are behind those changes, and so forth. Now, clearly, we don't live in that world, and science doesn't always flow directly into management like that. And so why? Well, there's a lot of reasons. One of them is that managers are bound by legislative mandates that tell them what they need to focus on and what they need to do. And most of their attention is focused on meeting those mandates, and often they're in crisis management mode, so it results in limited bandwidth to take up new ideas and new mantras and new paradigms that scientists are always throwing at them. So that's one reason. Another is that they might not, so managers have a lot of gaps that are clear to them, like we really need to know what this limit is for nutrient loading. We really need to know what is causing this hypoxic event, what are the drivers. So those gaps are clear. There are known unknowns, but like all of us, managers also sometimes don't know what they don't know. So these are the unknown unknowns. And that's important when you structure research. Part of designing research that is going to have an impact on management is to meet managers where they are and answer questions that are already salient for them. But another part is trying to figure out what they don't know, but they don't yet know that they don't know. So you try to get ahead of the curve a little bit. The third reason is on the scientific side. Some of us are driven by curiosity about the natural world. Some of us are driven to test theories and advance knowledge. And so we ask questions that are designed to do that. But sometimes those questions are not related or relevant to the kinds of problems that managers are facing, which are often very thorny and not amenable to testing, right? So they're not great scientific questions sometimes. Well, what can we do with all this information about why it's not working? Here's some lessons that I've learned with the Ocean Tipping Points project and in my own work at EDF with a whole bunch of managers around the world. One of them we've already touched on, and that is to use participatory processes to co-create knowledge with managers and stakeholders. What do I mean by that? It's the two-way street that Ashley was talking about, that the Ocean Tipping Points project, for example, has established with our expert managers. It's not just that we're talking at each other, but we're actually communicating, meaning that we're sharing knowledge to create a new body of knowledge that is better than the sum of the parts. With stakeholders, it means trying to elicit the local knowledge and experiential knowledge that they've gained by being on the water and working with resources, not gained in a scientific way, but gained in other ways, and melding that with whatever data you can find and whatever science you can bring to bear on how that structure, how that system works. So participatory processes. The second key lesson is to really take the time to understand the key audiences that you're trying to move or that you're trying to socialize this science with. So in this case, with the Ocean Tipping Points project, it's managers, sometimes it's managers and stakeholders, sometimes it's managers, stakeholders, and other NGOs, sometimes it's government. So whatever it is, identify the target audiences and examine what their needs are, where they are, what their knowledge level is, and that will really be very helpful in constructing a science delivery strategy that will work. For example, in my work with the Belize Fisheries Department over the last 5 or 6 years, it was really important to not only understand the knowledge gaps that managers needed to transform their coral reef fisheries into a more sustainable mode, but kind of institutionally and culturally, we needed to understand where the managers were in terms of needing to own the scientific process and the data analysis, and their lack of capacity to do so immediately. So we didn't want to go into a training mode, for example, because that kind of assumes that we are delivering knowledge to them, right? That would kind of cut against this need to really own the science. So instead, we use more of a coaching model and the co-creation of knowledge and lots of participatory workshops wherein we take the time to clean up the data together, instead of doing it in our shop. We take the time to develop the performance indicators of the fishery together, so everybody agrees on what they are. We take the time to evaluate those metrics with the data together, even though it's way less efficient. And I think it's starting to pay off now because these managers have fully internalized these ideas because they've co-created them and because they've learned how to use the tools that we've developed together. And most importantly, I think they've gained the confidence through all of this processing to actually use the science for the first time. This is a big breakthrough for Belize, to actually manage fisheries based on data instead of sort of a feeling for how to do it. I already mentioned this, but let me say it again because I think it's really important. So it's kind of defining scientific research that is going to matter and is going to be salient. So again, it's talking to managers and getting a sense of what the major gaps are that are impeding their management progress, and those are the things that they know about. But it's also really, really useful and sometimes really transformative when you have an idea or you look at data that shows an insight into nature that is completely unexpected. And I think, and it's not on the manager's radar screen, so they can't tell you, right, when you have that dialogue with them, we need this information. I think the Ocean Tipping Points kind of falls in that category. Even though, as Ashley said, managers are quite familiar with thresholds, they're usually with respect to single drivers. So here's a nutrient loading limit that translates into a total mass daily limit that is made operational in controlling non-point source pollution, for example. But the Ocean Tipping Points project is moving in a somewhat different and more expansive direction, looking at a whole bunch of different systems, firstly, and showing that these tipping points are quite common in ocean ecosystems. And also looking at many, many drivers at the same time to understand the safe operating space in a multidimensional way for the whole system. And finally, a lot of us, one obstacle to making science matter or bringing science to action is that many of us, myself included earlier, assume that there's an information deficit, and if only we can fill that deficit with information, people will take rational action. They will act on the science because the science is compelling, right? And now we know, and it's not going to be a surprise to most of you if you think about your personal lives outside of science, a lot of decisions are not rational. They're in fact predictably irrational, as many authors have put it. And the trick is to try and understand the chain of events and factors and incentives that will motivate action after the information is delivered. So co-creation knowledge is one of those mechanisms. Another mechanism is to try to find the window of opportunity when managers are ready to hear your science. So I can't tell you how many times I've gone to a fishery council meeting or something and presented a bunch of science that I thought would be, life-altering, and it can just completely bounce off. It just fell on deaf ears, and you get that sort of glazed look, like I do not care, and I do not hear what you're saying. And I think that's because it was the wrong time to be delivering that particular message. Kind of an example is the fishery right off here, the Pacific groundfish fishery that many of you probably know well. In the early 90s, it became clear to me that the catch limits were far too aggressive, but I didn't have much evidence to support that, and the weight of the available science suggested that the catch limits were just fine and would ultimately result in maximum sustainable yield for a whole range of species, including these kind of low productivity rockfish that I was worried about. So, the scientific arguments that I was making, that you need marine reserves to allow these rockfish to recover, you need big fish to produce lots of eggs. That came out of the research that Steve Berkeley and others had been doing on megaspawners. And you need some kind of a catch share system to introduce flexibility into the fishery management regime so that people wouldn't have to throw away all those fish. And that was constraining the fisheries, so that would open up all kinds of fishing opportunity. I thought these were really great arguments, but again, they fell on deaf ears and they had no traction until about the year 2000 when the fishery collapsed. So it turned out, of course, that some of the rockfish indeed were not as productive as the data were indicating at the time, and they did crash, and it did constrain fishing efforts. So suddenly a scientific debate became a debate about human values and economics and social disruption, job loss, and it became much, much, much more salient and available. These are the terms that cognitive scientists use to describe knowledge that is uptakeable as opposed to bounce offable. And so in 2000, we had an opportunity to make the case again. So the key thing there is we didn't go away. We just kind of kept coming at them until the opportunity presented itself to be heard. And this time, the science kind of caught on, the catch limits were adjusted, the pre-closed areas were put in, the ITQ system was created, and now I think we're on the road to recovery in this fishery. So, the basic idea here is that science and ideas and arguments are indeed very powerful, but we just have to remember that there's a lot of forces and factors that are arrayed against new ideas that challenge the status quo. And if you want to be successful, you need to understand those factors so that you can either find the right time to deliver the science Or if you're an activist type of person, you try to create the conditions for receptivity by increasing the salience, by precipitating a crisis, by pursuing a lawsuit, whatever lots of mechanisms you can use to increase the salience of your new science. So let me just summarize these key points. So one is to always engage your target audiences to co-create knowledge in a participatory way. And, like Ashley was saying, this is kind of a hot new language, and everybody knows that you need to use participatory processes, but when you actually do these things, it's really hard. It took us like 10 years in Belize to do this instead of like one training. So there's a lot of cost to that, but the hope is that the upfront costs will pay off in kind of longer term dividends because everybody's bought in and there's less conflict around what you're trying to do. The second one is, again, this idea of not assuming that you understand your audience, because unfortunately some of us live in a bubble, and when we actually go out there in the real world and try to change things in a fishery or in a coastal community, we have no idea really what people care about or what they need. So let's ask them and learn from them. The third kind of lesson, I guess, is to try to define research topics and ask questions that are going to be relevant to management, even if they're not the cleanest, most elegant, wonderful scientific ways. And I know that a lot of students, and I used to be a professor, and I used to say this to my students all the time, find a really tractable research question, right, that you can answer in a couple of years, that you can test in a rigorous way. That's the key to getting a PhD, but it's not always the kind of question that managers are grappling with. Those are usually really thorny, complex, and difficult questions that cannot be answered in those ways. And then finally, let's get over the information deficit model. We know it's not accurate. We know that people don't respond in that way, and they need more than information. They need knowledge. They need to turn the information into knowledge. They need to embody that knowledge, often through dialogue with peers, for example, and trying new things for themselves, and by coaching people to articulate their own goals and aspirations and needs so that they really own the science. So let me stop there, and maybe Laura, you can lead us through the next phase of this evening.